Assalamualaikum warahmatullahi wabarakatuh and hi, my name is HIDAYAH binti AZHAR and I would like to explain for the part A question for our group that we need to solve the problem about radioactive decay. Radioactive decay is a radioactive process in which a nucleus undergoes spontaneous transformation into one or more different nuclei and simultaneously emits radiations, loses electrons, or undergoes fission. Radioactive materials decay at a rate proportional to the amount of material present. Nt is the number of radioactive material for any time at t, N0 is the initial number, and delta N over delta T is the rate of decay for the material. The rate of decay is proportional to the number of material, or delta N over delta T is equal negative Rn, where R is proportional constant, and we will use K as a proportional constant for our solution in this project. The negative sign is indicate the decreasing or the decaying of the material. Firstly, we need to solve the first order separable ODE, where N can be found by solving the ODE. After we solve the first order separable ODE, we will get N is equal to A e the power of negative RT. So, after we get the N equal to A e the power of negative RT, we will substitute T is equal to 0 and N is equal to N0 into this equation. After all, we will get the equation Nt equal to N0 e the power of negative RT. This is the equation of the decay model. But when Nt is equal to 1 over 2 N0, the time taken is called half-life of the radioactive material. And what will we do? We will solve the equation to find the value of T for the half-life of the material. So, this is the part A question for our group, that we need to verify the rate of decay for the radioactive substance Y, and we use formula of Mt is equal to M0 e the power of negative Kt to find the remaining mass of 100 gram after 200 years for the radioactive substance Y.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad FAZLI NAJMI bin Muhamad. Today I want to present about solution for the question part A number 8, radioactive decay. The question is the rate of decay of a radioactive substance Y is proportional to the mass of substance remaining. The mass of Y is Y gram at the time T years after decay. A particular radioactive substance takes 600 years to be half of its original mass. Find how much of 100 grain sample will remain after 200 years. So, we actually know that the first step for this question is we need to find the value of K. The formula of K is natural log of 2 divided by half-life, which is the half-life of this original mass is 600 years. And then K equal to natural log of 2 over 600 years. And then we got the K is 1.1552 multiplied with 10 power of negative 3. And then we go to the next step is we put all the values that we have into this formula. Mu e power of negative Kt. The negative means the radioactive was decay form. The sample mass will remain decrease all over time. That's why we have the negative. And then Mu is the original mass. Original mass is 100 gram. E power of this is K and T 200 because the T that we want to find, T is 200 years. And then 100 multiplied with 0.7937, and then we got the after 200 years the sample mass will become 79.37 gram.
Hi and Assalamualaikum. My name is ADEBAHANIM with MISNAN. Now I will explain about Fila table in problem part B, question 5. The question is, a bottle of water with an initial temperature of 25 degrees Celsius is placed in a refrigerator with an internal temperature of 5 degrees Celsius. Given that the temperature of the water is 20 degrees Celsius 10 minutes after it is placed in the refrigerator. The question is, what will the temperature of the water be after 1 hour, and at what time will the temperature of the water reach 6 degrees Celsius? The fact is, the first one, a bottle of water with an initial temperature of 25 degrees Celsius. Second, the refrigerator with an internal temperature of 5 degrees Celsius. The third one is, the temperature of the water is 20 degrees Celsius 10 minutes after it is placed in the refrigerator. The ideas that we apply in this question is, first, apply knowledge on application of calculus in the Newton law of cooling in engineering maths 2. Second, verify the value of initial temperature, temperature of object and environment. Third, identify the value of cooling K and substitute into formula to identify the temperature with the time given and identify the time with the temperature given. The learning issue is, what the value temperature of the water be after 1 hour? Second, at what time will the temperature of the water reach 6 degrees Celsius? Action plan or resources needed. First, discussion with group member to solve the problem. Second, identify the solution. Refer to the module of engineering maths 2. Third, resources from the internet, which is YouTube.
Assalamualaikum. My name is Haziqah binti Muhamad. Now, I want to show how to solve the problem for question part B, which is Newton's law of cooling. This question is, a bottle of water with an initial temperature of 25 degrees Celsius is placed in a refrigerator with an internal temperature of 5 degrees Celsius. Given that the temperature of the water is 20 degrees Celsius, 10 minutes after it is placed in the refrigerator, what will the temperature of the water be after 1 hour? At what time will the temperature of the water reach 6 degrees Celsius? Okay, now, this question one way to find. First is, this question one way to find what will the temperature of water be after 1 hour, and what time will the temperature of the water reach 6 degrees Celsius. So for the solution, let's identify all the information given up from this question. So from this question, we will get the T0 is equal to 25 degrees Celsius, which is a bottle of water with an initial temperature of 25 degrees Celsius. Then we will get the temperature of environment is equal 5 degrees Celsius, which is a bottle of water is placed in a refrigerator with an internal temperature of 5 degrees Celsius. Then the question gives temperature after 10 minutes equal to 20 degrees Celsius, and we should find what is the temperature after 1 hour, which is 16 minutes, and what is the time when the temperature is reached 6 degrees Celsius. So after we find the information given up from the question, so we insert the information given to this equation. TE is equal to 5 plus, in parenthesis, T0 equal to 25 minus TE equal to 5 multiply E power negative KT. So when we solve this equation, we will get the temperature of the object at time T is equal 5 plus 20 E power negative KT. Next, we want to find value of K. We are given the temperature after 10 minutes is equal to 20 degrees Celsius. So we substitute this information into the equation. So when we substitute this information into the equation, we will get 5 plus 20 e power negative k multiply 10 equal to 20. Then 5 we will transfer to the right side, and we will get 20 e power negative 10k equal to 20 minus 5. And we solve 20 minus 5, we will get equal to 15. Then we will transfer 20 to the right side and we will get e power negative 10k equal to 15 over 20. To eliminate e, we should ln both sides and we will get negative 10k equal to ln 15 over 20. Then we transfer 10 to the right side and we will get the value of k is equal negative ln 15 over 20 divide 10, and when we calculate by calculator we will get k is equal 0.0288. Then we update the value of k into this equation, which is the temperature of the object at the time t is equal to 5 plus 20 e power negative 0.0288 t. Now, we want to find the temperature of the water B after 1 hour. So, we substitute the information that have given to this equation. So, we will get the time of this equation is 16 minutes. So, the temperature at time 16 minutes equal to 5 plus 20e power negative 0.0288 times 60. We will get the total is 8.6 degrees Celsius. Next, we want to find is the time where the temperature of the water reach 6 degrees Celsius. So, we substitute again the value of temperature into this equation. So, we will get 5 plus 20 e power negative 0.0288 times t equal to 6. We transfer 5 to the right side and we will get 6 minus 5 over 20 equal to 1 over 20. So, when we have e at the left side and we want to eliminate the e, is we should to ln both sides. So, we will get negative 0.0288 t equal to ln 1 over 20. To find the value of t, we should transfer negative 0.0288 to the right side, and it will be ln 1 over 20 divide negative 0.0288, and the value of t is, when we calculate by calculator, we can get 104.0185 minutes, and then we convert the value of in minutes to the hours. We will get the answer of t in hours is 1.73 hours.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURANIS binti SHAMSULAKMAR, matrix number AA190143. Today I'm going to continue the presentation by presenting discussion and conclusion from this PBL, Engineering Mathematics 2. So both Newton's law of cooling and growth and population are one of the few examples of application of first order differential equation. Usually, we tend to assume that growth and population, also known as growth and decay, will be a discussion of exponential. Example of exponential growth are radioactive decay, carbon dating, and compound interest. In this topic, the independent variable will be considered as t, as it deals with the function of time, and any derivative will be written as respect to t. Newton's law of cooling states that the hotter an object is, the faster it cools, in which, to be precise, it means that the rate of cooling is proportional to the temperature difference. The interpretation of Newton's works goes way back from 1701, and since then, scientists has considered this law as a fundamental principle rather than conflicting it by doing different types of experiments. In conclusion, first-order differential equation has plays a crucial role in applications of sciences, especially engineering. It is applicable in different fields, whereas the equations can basically solve any analytical or numerical method. That's all from me. Thank you.